Welcome back to Outward Home Learning. This is computer science and the topic today is variables and constants. So to find out a little bit about what variables and constants are, we're going to go over to Mr. Holton, who's going to tell you all about it, and then there's going to be some tasks for you to complete. Over to Mr. Holton.
Variables and constants then. This is one topic which variables in particular sometimes throw people off a little bit. So I'm going to go through the definition to start with, and then I'm really going to give you some examples of how these are used in code, and then hopefully it will start clicking. We'll give you the definition up first though. So right, here we go. A variable is a location in memory that contains data which can be changed. That is the absolute 100% dictionary definition of it. But let's explain what that actually means. Okay, so here we go with some computer code on the left then. Let's do, I know which one we should do. So I'm going to create a variable called best teacher. It's two words, but there is no space in it. That's one thing about variables. You can't have spaces in them. So the second letter's shown by having a capital letter. So best teacher equals, and so I'm going to put a string into that. Don't worry about strings for now if you're not sure what they are. Mr. Holton. Okay, so best teacher equals Mr. Holton. Let's break down actually what is happening in that one line of code, because actually it's a fair bit. If you get into your head the idea that every variable is like a box somewhere in the computer, okay, so a variable is like a box. I have just created a box. I put a label on it, or given that box a name, best teacher, and then I have put a value in it. And the value that I've put inside it is Mr. Holton, okay? That is how you should think of a variable, as a box with some data in it. The fact that I've done this here, equals, look at that, equals, means that I have put data into the box. I put data into that variable called best teacher. So Mr. Holton is now in that variable called best teacher. Let's do another one very quickly, and you can probably see how this is going to go in your head now. So my num equals 6. Same thing again. If you imagine I've got a box here, it's got label my num, and it's got the value 6 in it. All right, that is a variable. Now I've got data in my box. The question is, of course, how do I get data out of the box, and how do I do something which is useful with it? And basically, any other time that you use the variable name after you've done this something equals, any other time you use that variable name, you will be taking data out of that box. Let me give you an example if that's not making sense to you. Print, this word here, print, will print a variable to the screen. So print, let's do best teacher. Okay, so print the best teacher. So what is happening there? Print tells the computer that something wants to be printed to the screen. And then because you're using these words here, best teacher, you're going to use what's in this box. So that's going to be Mr. Holton. So the words Mr. Holton will appear on the screen. Likewise, if I do print my num like this, then you are going to get, and you guessed it, the number 6 printed to the screen. Okay, but let's have a look at something, because we've got this idea of variables. Okay, so location in memory, just like a box, that contains data, Mr. Holton, that can be changed. So what I can do, I've done this, my num equals 6, but look what I'm going to do now. My num equals 8. Okay, if I do that, then basically I'm putting 8 into my num. So what happens over here? Well, 6 goes away and I get the value 8, and that goes into my num, which means now if I print my num afterwards, then I am going to get not 6 this time, but the number 8. Makes sense? That's what the beauty of variables is, that you can change them and you can do all sorts of tricks with them, which makes them especially useful. Right, so that's variables. So what are constants? Well, they are nearly exactly the same. So let me give you the definition of a constant now, and it's fairly simple. So constants, they are a location in memory. So that should sound familiar. They're a location in memory that contains data that, wait for it, cannot be changed. Okay, so let's have a think of a practical example for this now. So let's have, okay, so this is how we declare a constant. We have to have this word here, const. Now it's different in different languages, but there's usually some sort of identifier that we're declaring a constant. There's a convention here and there when we're declaring constants to always have them in capital letters. So const sky color, and I'm using that little underscore there for because this is two words. So const sky color, equals blue. Okay, exact same sort of thing as a variable really. We're going const sky color equals blue. If I did print sky color, okay, print sky color, then I would get the value blue printed to the screen. So that is very similar. However, this is the difference between variables and constants. I cannot do this. I can't do this. In fact, let's make it clear. Let's put it in a different color. Okay, this is what I cannot do. Sky color equals white. And the reason why I can't do that is because the value in sky color, once I have set it, cannot be changed. So this would throw a syntax error and it would stop your program from compiling. So that just plain out won't work. Okay, so that's your constants. All right, one thing to be just to be careful of, okay, here, if I had a let's do this, say I had a variable, let's do grass color. Okay, so grass color, and let's say I've set that to green. Okay, that is still a variable. There's nothing here saying const. All right, there's nothing here declaring it's a constant. So grass color is green. I haven't changed the value in grass color at any point in my program other than once, but that doesn't make it a constant. It could be changed. Okay, so the definition of variables is that it can be changed. Constants need to be declared as constants and they cannot be changed. Just because a variable has been changed once, it still makes it a variable, doesn't make it a constant. I hope that's sort of clear. And they are your definitions and examples for variables and constants.
So for your first task, you need to identify some variables and constants in various algorithms. So you need to get that activity open now, and then you're going to get 10 minutes to complete the activity. If you need a little bit more time, you can always press pause, and then we will review the answers afterwards. Off you go. So that's time up. As ever, we're now going to go over to Mr. Barnes. He's going to review those algorithms and help you pick out those variables and constants. So if you need to correct any of your answers as you go, please do. And then you've got those for revision. Over to Mr. Barnes.
Okay, so hopefully you've had a go at this activity about variables and constants. Just going to run through it now and make sure we've got that understanding in place. So starting at the top, you were asked to give a definition of a variable. Okay, so hopefully you put something along the lines of a variable is a value in a program that can be changed as the program is run. Spelling mistake there. And for a constant is set, is a value that is set and cannot be changed when the program is run. Okay, so a constant, for example pi 3.14, it's set, it does not change when the program is run. Remember, constants can be strings, they do not have to be numbers. Okay, so the next part is label the diagram to identify variable, assignment, constant, casting, input and output. Okay, so here in our red box we have it pointing towards float. Okay, now float is a way of casting the data types. So input is taken as a string and float will convert it to a decimal number. The orange box is pointing just about at the input, so unsurprisingly that is an input. Here we've got pi equals 3.14159. Well, that is setting it and it is not changing. Therefore, that is a constant. The next one is some calculations. Volume equals and surface equals. Okay, there's some calculations going on there, but those are pointing at variables. They are variables because they can change depending on what the radius and height are. And finally, in the blue box, it's got print, which is output. So the one missing from here, it's not actually missing, it does exist, is assignment, where it sets a value. So for example, height equals, that single equals is the assignment. But there is not an option to enter that on this example. The final piece then is the algorithm below records the highest and lowest numbers entered by a user until they're done. Identify the variables from the algorithm above and describe what they do. So we've got 3 variables in here. Number is one of them, but I've not said what it does. Okay, the other 2, we've got highest and lowest. So number, based on the input here, this stores the number entered by the user. Highest then stores the highest number that has been entered so far, and unsurprisingly lowest stores the lowest number that has been entered so far. So variables can change when a program is run, constants can't when a program is running. We can change the data type of variables using casting.
Now finally, we're going to do some exam questions on variables and constants. So if you want to open up that task, give it your best shot. You've got 10 minutes and then we will review your answers afterwards. Okay, that's time up. So let's go over to Mr. Barnes. He's going to review your answers. Please make sure you correct anything that you didn't get quite right. Over to Mr. Barnes.
Okay, so you should have hopefully completed the activity where you've had to drag and drop the different statements under what type of language. So now let's have a look at some exam questions. So we've got a games developer is developing an online game that can be played on games console, desktop computers or mobile phones. The program is written in high-level code and translated to machine code. Describe two differences between high-level and machine code. So it needs two direct comparisons. Okay, for each comparison you will get 2 marks with a total of 4. So the thing I always go for straight away is high-level code uses the English language and is written in words. Okay, and then I follow that up with machine code is written in binary code. Okay, so I've got one direct comparison, now I need another. So I'm going to say high-level code is to be read by the programmer. Okay, and machine code is to be read by the computer. I'm just going to add on to the end, high level must be translated. Okay, so there we've got my answer. Now we're going to have a look at the mark scheme and see where else you could have got marks. So, first point, we've got high-level code uses the English language, written in words. Machine code is written in binary. So as you'll see here, we've got EG, which means this list of answers is not exhaustive. So we've got high-level code uses words, 1 mark. Machine code is written in binary, 2 marks. And then I've got high-level code is to be read by the programmer. So down here is to be read by the human. And machine code is to be read by the computer. So that meets these 2 marks. You can also have said that high-level code can be portable or translated for different machines, but machine code is specific to the machine, and there are other comparisons you can have as well. Okay, one thing that's worth noting here is you could not have got marks for saying high level needs to be translated and machine code doesn't, because that is in the question, so it's really important to read the question there. Okay.
And that's what you need to know about variables and constants for computer science. See you next time.